And what logic I'm telling you today, it applies only for BST, not any other binary trees. There are many binary trees you might be knowing, but many types will be there. But what today I'm teaching, that logic is only for binary search tree. So before constructing the binary tree, let's learn the basics of binary tree. Okay, so this is the binary tree where you can just see there is a root part, left part, and the right part. Okay, so you can see here the root is highlighted in the third diagram and leaves are highlighted in the right side. You can see what are the leaf nodes, the nodes which will not lead to any other nodes. So those nodes are called leaf nodes. You can see there are 4, 5, 6, 7, 8. There are 8 leaf nodes in this diagram. And what are the child nodes? Other than root nodes, all other things are called child nodes. Okay, so next you can see the basic rules of the BST. See, the root node is the middle one. The left side you have a node and right side you have a node. Both are called child nodes. So what is the rule is, if the root node has some number like 10, the left side should be lesser than the 10, lesser than the root node, and the right side, whatever the value is there, it should be greater than the root node. So that is what given here. So this is one of the basic rule. And there should not be more than 2 child nodes. That's why we will call it as binary. Binary means 2. So only 2 child nodes should be there. You can see here X is the root node. So the left side means contains only smaller values. All values should be lesser than X. They have given equal to, but usually we will take only lesser, equal to will not be there. Okay, and all the right nodes should be greater than X. You can see here, this is one of the example. 5 is a root node. To the left side it's 3, to the right side it's 8, means you have to follow the rule that left side should be less than root, right side should be greater than root. This is one more example. See, if you want to find any element like 30. So here you want to find the targeted element 30. So in which path you go? You will never go to left because you will find that root node is 20 and it should be, if you want to find an element, it has to be in the right side. So when it comes to right side, it is 32. Then if it is 30 is the element, it has to go to left side because always all the left side nodes should be lesser than the root nodes. So this is the path we will follow. And after coming to the left side, you have 27. And now left or either to right, it has to go. It has to go to right because the element, key element which you have to find is 30, which is greater than 27. Okay, this is left subtree and this is right subtree. What is left subtree? 12, 6 and 15. The right subtree is 32, 27, 40, which you are looking at here. Okay. Now, if you want to add a new element 17, so you can just see here, you want to add a new element 17. How do you know that you have to add it to the left side? You have to add it to the left subtree because all the left should be less than the root node. So 17 is less than 20 when compared to the root node. So if you want to add 17, you have to come to the left subtree. So what is there in the left subtree? There is 12, 6 and 15. So you have to go to the root first. See, 12 is there. Will you go to the left or will you go to the right from the root? You have to go to the right because 17 is bigger than 12. So again you will go to the right subtree. When the right subtree comes, there is only one element, that is 15, which is considered as the root. Now to the root, will you attach the 17 towards left or towards right? You have to attach that 17 towards right because it is the BST and all the right elements should be greater than the root node. Okay, I think no more will be joining. the class. For latecomers, and this is called the unbalanced tree. Okay. For latecomers, I'm repeating. Today I will be teaching the concept of BST and how to construct a binary search tree only when pre-order and in order, sorry, in order will not be given, only when pre-order or post-order is given. Okay, so just check this. It's a binary tree. So it should have leaf nodes either 1 or 2 or 0. Okay. And these are all the child nodes, the left corner. Here you can see the leaf nodes which will not be having any child. And the highlighted one, only the root is the main one. So what are the basic rules? The main node, the root node will be there. The left side of the root node should be always lesser than the root. And the right side of the root node should be always greater than the root. So this is an example. 5 is a root here. 3 is a left node, 8 is a right node. So you have followed the rule. This is called BST. And this one, if you want to find an element 30, 30 is a key element. You will be comparing it with the root element, that is 20. So 30 is greater than 20 means you will directly go to searching the searching process with the right subtree. You will not go to the left subtree. So in right subtree, you have 32 is the next root. Again, 30 is the key element. When you compare with the 32, it has to go to the left subtree because 30 is lesser. You will just leave off the right subtree. When you go to the left subtree, you have the root as 27. Now 27 is there. 27 is lesser than 30. So again you have to search in the right. So there you found an element called 30. So this is the path you have used to find an element, the key element compared to other elements. Now, if you want to add a new element called 17, I'm not teaching you deletion here. I'm just telling you the addition because it will become more complicated. I want to make the concepts much simpler. Now, when you want to add up 17, so what you will do, this is like you will find the path. 17 will be compared with the root node. Then you will just leave off the right one because 17 is lesser than 20. When you come to the next root, it is 12 is the root. Again, 17 is bigger than 12. You just leave off the left part, that is 6. You will leave off and you will come to 15. 15 is a root node which is not having any child. So you have to insert that 17 towards the right because 17 is greater than 15. So the right side what you found is the BST. Yeah. And what is an unbalanced tree? This is called an unbalanced tree, but still it's a binary search tree because every node has either 2 nodes, 2 child or 1 child or 0 child. Okay. Yeah. So any doubt with the concept still now what you learned? Students, you can please acknowledge. Till now I taught you the basic rules of BST. Any doubt with that? Can I get some response?
No, ma'am.
Okay, so no doubt. So we will continue. Okay, students, I'm sharing the screen. Just acknowledge me once you see the screen. Are you all able to see the screen?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Yeah. So, what is pre-order? Can anybody tell me? So, root comes first, left trees comes next, and right will come at the end. So, they have given you an array of numbers, and they are telling that the particular number of the tree is in pre-order. So, what will be the root here? Don't worry about the left subtree root or right subtree root. Just tell me what is the root here in the pre-order given. Anyone? Okay, 20 is the root because in pre-order root comes first. Okay, just remember that. Now, first convert how to construct a binary tree by using this pre-order. So you can see I have highlighted the 20 and I have underlined. So that will become the root. Now, how to convert that pre-order to in-order? And this logic, do remind, do remember, it. This logic applies only for BST in-order. Don't blindly apply it to all other things. Okay, so in-order means the given order will be, in-order will always be in increasing order. Okay, so you can see all the elements here. How many elements they have given? 4, 8, 9. Okay, they have given 9 elements. So this 9 elements, if you just what to tell, if you just put it in the sequence in the increasing order, it will become pre-order. Again and again I'm repeating, this increasing order of the numbers applies to only in order of BST, not to any other trees. Am I clear? So now, what is in order? In order is left, root, right. So just make a note of it. Now, when you construct a binary tree, the root should be in the middle. When you have this pre-order and in order together, what is the root? You, from the help of, with the help of pre-order, you have found that root is 20, because the leftmost, the first most element, whatever the first element is, the will be there, that will become root. Am I clear till here? Is it clear? Are you able to understand? Or please don't blindly listen, this technique is very interesting.
Yes, ma'am.
Yeah. Okay. So what is pre-order?
Yes, ma'am.
Root left. Yeah. Root left, right. And the leftmost, the first, very first element is the root. And what is in order? How do you convert the pre-order or post-order to in-order is, in order, in order will always be in increasing order. Okay. Sorry. Yeah. So now consider the in order. So according to the previous slide, you found that 20 is the root. So what you have done, you have taken 20 as a root and all the elements towards the left. How did you come to know that you have to take all these elements towards left? Because all the elements are lesser than 20 and all the elements which are greater than 20, you will push it to the right tree. So the left one, what you are seeing in the oval is the inside that tree, the set, inside that set is the left subtree, and this will become the right subtree. Now, how to find out that root? What is the root in the left subtree? That is 5, 16, 17, 18, 19. So I will give you, I will tell you. So you can just consider, just check what is pre-order, what is in order. Now, according to in order, you have written 20. Okay, and you have written the left subtree, you have written the right subtree. Now, first finish off the left subtree and construct a binary tree while constructing. Now, when you consider the pre-order, which is the next element which has come in the order, that is 16. So 16 will become the next root. Did you understand or not? If it is not clear, I will explain you again. Is that clear? Yeah,
No,
guys,
no, ma'am.
not clear.
Mm-hmm.
Okay,
Please explain.
yeah. See, I will take this. See, we have two strings, two arrays here. One is pre-order and another one is in order. In pre-order, always the very first element will become the root. Okay, why? Because the pre-order itself is root, left, right. Okay, I have a doubt. Have you studied trees in your DS?
Yes, ma'am.
Have you studied binary search tree?
Yes, ma'am.
Okay, and then it will be clear. Okay, so when pre-order is given, the very first element is the root. See, while constructing a binary tree, you have to keep track of both pre-order and in order. How did you got in order? I told you, you just write all the numbers, all the array elements in the sequence, you will get the in order. Okay, in this in order, how did you find what is the root? With the help of pre-order, you found out that 20 is the root. Am I clear till this part?
Yes, ma'am.
Pre-order, yeah, till here it's clear. So now, when 20 becomes the root, all the elements which are lesser than 20 should go to the left tree, and all the elements which is greater than 20 should go to the right tree. Till this, is it clear?
Ma'am.
Till, huh?
Yes, ma'am. Yes,
Yeah,
ma'am.
till here it's clear. Now, what was in the last slide? I have just put this in the upper part. In this upper part, now you have in order elements. You have 20 in the root, and the left subtree is having some elements which is lesser than 20, and right subtree is having few more elements which is lesser than, which is greater than 20. Now tell me, to construct the left subtree, you should get a root, yes or no? So among this 5, 16, 17, 18 and 19, how to find out which is the root? So now come to the pre-order array. You can see the pre-order array initially what was given. Now 20 is considered as the root and it is over. Am I correct? So the next preference root will be the next number which comes after 20. So now 16 will become the root node for the left subtree. See how many nodes are there in the left subtree? There are 5 nodes: 5, 16, 17, 18 and 19. So how to know that which is the root? So just go to the pre-order, move off that 20, because 20 you already know it's a main root. Now to the left subtree, 16 will become the root node. Now again, when you split this tree, how do you know which has to go to left and which has to go to right? Can you tell me? When you found that
Yes, ma'am.
6, yeah, how did you know that 5 has to be at the left?
Ma'am, 5 is lesser than 16, so it have to come to the
Exactly.
left.
Exactly. 5 is lesser than 16, so it has to come to the left, and all the remaining elements are greater than 16, and it has to come to the right. Am I clear now?
Yes, ma'am.
Now is it clear? Everyone, others? I hope it's clear for others also.
Yes, ma'am.
Yeah. Okay. So now what happens? Again, when you consider the pre-order, what is the next number? The next number is 5. 5 is the root. Is it correct? Is this correct?
Yes, ma'am.
Yeah, 5 is a root, but it has no children. Correct. So again, you will go next element to the 5 is 18. Now, what is there in the this tree, in the child, in the subtree of the left subtree? Are you able to understand? Subtree, right? Subtree of the left subtree. There are 17, 18 and 19, 3 numbers. But when you take this pre-order, now 20 is done. 20 was the main root. 16 is done because 16 was the root node of the left subtree. 5 is done because 5 is also the root, but it has no children. Now what is the root? The root will become 18. Am I clear? Everyone?
Yes, ma'am.
Everyone, am I clear? Yeah, tell me. I heard only ma'am. Is it yes ma'am or no ma'am? I don't know.
It is yes, ma'am.
Yes ma'am. Okay, good. So when you get 18, there are only 3 numbers, 17 and 19, correct? So obviously the lesser number will go to the left and the higher number will come to the right side. I have missed 19 here. Okay, I have missed 19. So, um, Okay, let me make it off. Just a second. So here you will get 19. The same here. Here you will get 19. Yeah. So now you have to concentrate on now you have to concentrate on the right subtree. So you got all the child trees, and now what is there in the right subtree? You have 60 comma 70 comma 85. Can anybody tell me which will become the root? Please tell me which will become the root and tell me what is the reason. Anyone? Students? Anyone please? Pooja? Why did 60 become the root? Please respond.
Ma'am, it is next to root, no, ma'am.
Yeah, which root?
First 20 have come and later it have come 16. So even 60 have to come. So later it will be 85.
See, 18 was the root
Ma'am,
I told. Yeah, 17 was the. Yes, tell me. Okay.
Ma'am, like suppose 60 should be near to 20, ma'am. Like 70, 85 is greater than
No, here
60.
greater than and lesser than will never come into the picture. See, just come in the pre-order. See, 20 was the root which you found. Correct. Next was 16 the root. 5 is also the root, but no children. Correct. Next, 18 was the root. After 18, you have finished with 17 and 19. They are also considered as the root for that particular tree, but it has no children. Am I correct? Now, in the after finishing all these things, in the order you have 60, so 60 will become the root. Am I clear now? So now after 60 becoming the root, again the subtree has the elements 70 and 85. Can anybody tell me, will 70 go to the left side or will go to the right side? Anyone?
Right side, ma'am.
Right side.
I'm
Okay.
right
Yes.
side.
Because, yeah, right side because 70 is bigger than 60. Yes. And after, oh, 1 second, just a second. Yeah. After that, sorry, I'm sorry. See, 70 and 85 are the two numbers. Again, you have to find out the root, like how you found out for 18. Correct. So in this one, in among the 70 and 85, which is the root node? How do you find it's a root? The same pre-order order will be taken. Please tell me which is the root among this 70 and 85.
85, ma'am.
85 is the root
85.
node. Yes, correct. 85 is the root node because it is now you have finished off with all the elements, that is 20, 16, 5, 18, 17, 19 and 60. So 85 will become the root node. And what is the one which is pending? The pending one was 70. That will go to the left because 70 is lesser than 85. So am I clear now how to construct a binary tree by given pre-order elements? Anyone?
Yes, ma'am.
Yes, ma'am.
Yeah. So was it a new technique, a little new technique what you learned from the academics?
Yes, ma'am.
Yeah, okay. So I hope that was clear. Whole class, can you give a thumbs up mark in the okay, if you give thumbs up mark, it will become join DS class at 11:15. Okay, students. Yeah. So I think okay. Okay, students. So I think uh, uh, okay. You can just try with more pre-order. If you want, I will give you the exercises. I will send you in the I will just put it in the WhatsApp or in Opera. Am I clear, students? Okay. So
Yes, ma'am.
In your DBMS, those who have enrolled to DBMS certificate course, okay, they have to solve the questions from 8 to 15. 15th one is the stack question. That's okay. You can solve it. It's very simple. So 8 to 15, you have to solve it. And good that yesterday Swaraj, Srikantaris, Sangeeta, Pooja sent me the answers. Correct? Anyone else I missed? I think 4 of you have sent. So thank you so much for sending the answers. And it was good that you are showing the interest. Okay, students. So bye bye. Have a nice day. See you. See you all.
Bye, ma'am.
Bye bye.